Okay, so I'm covering the next three libraries, and they're more math-based, starting off with Numpy. Okay, so Numpy is a great library. It deals with math and numbers, as you can see up there. It will remind you a lot of MATLAB if you've used MATLAB, but the good things of MATLAB, not MATLAB. Yeah, so does mathematical equations. It's really useful, powerful, and extremely fast because it uses other languages to actually do the computations like C and Fortran. So it's faster than anything you could write in Python. And the data types that it uses is in a lot of other libraries, which we'll see in a second as well. Okay, so we're going to first of all import Numpy. We name it NP because you're going to be using it a lot, and that's just standard. Okay, so the first data type is an array, which sounds like a, I know arrays, but these are extremely powerful arrays. So this one is same as creating an array of just range 15, so it's all the numbers between 0 to 15. Other handy ones you can do is np.zeros, which creates an array of just zeros, extremely handy, or np.empty, which gives you uninitialized arrays. Not always helpful, but if you know you need that much, it's handy to get it out of the way. So we can see here, you got an array 0 all the way up to 14, because it's exclusive on the end. So let's see some information about this array. You got the shape, which is 15 and nothing, so it's essentially one-dimensional array, 15 long. If we look at the number of dimensions, it's 1, and here's the data type that will be used by other languages, or other libraries, sorry, which is like int64, which is a 64-bit integer. Don't really need to know what that means, but look out for that in the next library. The other thing is size. So 15, not very interesting, but let's reshape it. So it's an array of 0 to 14, but let's say I want that to be a two-dimensional array of 3 by 5. Ta-da! So we can see that its shape has now changed. Its D type has not, because that's the data type of each element in the array, integer. And the size is still the same because the number of elements hasn't changed. Now this is pretty boring. We all know arrays, so let's do something with them. And this is the part that will remind you of MATLAB. Linspace, first of all. So this will generate 50 numbers between 0 and 2 times pi. As you've got 0 there, 2 times numpy.pi there, and 50. So that's linear space. If we output that, you have to trust me that that's 50 equally separated numbers between 0 and 2 pi. And now let's apply sign to it. And again, for now, you're going to have to trust me that's right. In few libraries, we'll see that that actually is right when we get to plotting. Spoiler. So yeah, that if you've used MATLAB, that will remind you a lot of MATLAB. It's really hard to show everything NumPy can do because it has a lot of cool stuff like fsolve, which finds the roots of an equation. There's just, if you need to do a math equation, look at the docs. So now let's do some other stuff. If we add to arrays, they add each individual item together. Same with subtraction, and even same with multiplication. Another popular example is dot product. So seeing as multiplication gives you element-wise multiplication, what if you wanted matrix multiplication? That's where you can use a NumPy matrix, where here we've got two Numpy matrices. One is 1, 2, 3 across, the other is 4, 5, 6 down. And we can times them together to get the matrix multiplication. So that's Numpy. Doesn't sound that interesting. I'm sorry. I didn't do it justice. It's better if you have, like, oh, I need to find the root of this equation, or I need to, you know, cos, tan, sine, all these numbers. Again, not doing it justice, but if you have a use for it, it's extremely powerful. So the that's the wrong one. So the docs of it are there. As you can see, it's SciPy, which is a similar library, same project. It also does math stuff.